participants, you intend to provide a jelly in a bowl shaped like a hemisphere with a diameter of 10 cm. A jelly formed like a sphere with a diameter of 1.5 cm and 3 cubes of 1 cm side coconut jellies as a souvenir. If the bowl is filled to a depth of 4 cm, how much jelly does it contain? It says that for a party with 350 calories, how much jelly and peanut jelly should it be?
Firstly, we find the volume of jelly, which fill the ball with the depth of 4 cm. Using the knowledge of Pythagorean theorem, we find the radius for the integral limit, which is square root of radius of hemisphere square minus radius of hemisphere minus depth square. Then, by using the knowledge of triple integrals in cylindrical coordinates, we set up the limits z ranges from 1 to square root of 25 minus radius square, and then r ranges from 0 to 2/6, and then theta ranges from 0 to 2 pi. During the process of integration, we have used the substitution method to solve. Then we get the volume of the jelly, which is equal to 176 over 3 pi cm cube. After that, we also calculate the volume of the cherry and coconut jellies by using the formula of sphere and cube, which are 9 over 16 pi cm cube and 3 cm cube respectively. The question asks for the net volume of jelly. Therefore, to calculate it, we use volume of jelly minus the sum of the volume of cherry and coconut jellies, which is 179.54 cm cube. We also find the total volume of net jelly and total volume of coconut jellies for 315 guests, which are 56,554.98 and 945 cm cube respectively. In real life, objects shaped like cherry and coconut jellies may not be perfectly spherical or cubic, and they may not be completely submerged in the jelly, which can lead to inaccurate calculations. To address this, we can assume the cherry and cubes are fully submerged, providing an upper limit on the volume they might displace. Observing their actual submersion can further refine our calculation for greater accuracy. In conclusion, the net volume of jelly is 179.54 cm cube, and the total volume of net jelly and total volume of coconut jellies for 315 guests are 56,554.98 and 945 cm cube respectively.
In question 2, we are designing a bar of chocolate that takes the shape of a tetrahedron divided by the equation 2x plus 2y plus 2z equal to 8. A spherical jelly with a diameter of 2 cm is placed inside the chocolate to enhance the flavor. The company has decided to launch a deluxe version of the chocolate, packaging 10 pieces in a beautifully designed gift box. The manufacturing department needs to know the amount of chocolate mixture required to produce 10,000 gift boxes. Each gift box contains 10 chocolate. Therefore, we need to calculate the total volume of chocolate needed for 100,000 pieces. In question 2, we simplify the equation for tetrahedron to the form z equals 4 minus s minus y. After that, find the equation for y by using y equals ms plus 6, and thus we'll get y equals 4 minus s. Next, to find the volume of the tetrahedron, we use a triple integral over the region bounded by the length s equal to 0, y equal to 0, z equal to 0, and s plus y plus z equal to 4. By setting out the limit of the integer, which are z range from 0 to 4 minus s minus y range from 0 to 4 minus s, and s range from y to 4 minus s, and s range from 0 to 4. We will get the volume of the tetrahedron, which is 22/3 cm cube. Then, we find the volume of the spherical jelly with a diameter of 2 cm by using the formula 4/3 pi r cube and get the result 4/3 pi cm cube. After that, we find the volume of the chocolate bar and get 22 per 3 minus 4 per 3 by cm cube. Finally, we find the total mixture of chocolate to have on hand of a production run of 10,000 boxes and get the final answer, which is 64778 cm cube.
In the conclusion, the total mixture of chocolate required for a production run of 10,000 boxes, each containing 10 chocolate, in approximately equals to 647,788 cm cube. This calculation assumes that spherical jelly with a diameter of 2 cm is considered entirely submerged within each chocolate shaped like a tetrahedron. This calculation do not consider any tiny displacement or departure in the real production process. Although the equation yield an exact theoretical volume, real-world manufacturing procedure could create discrepancies. It is important to consider variables such as tiny variation in a jelly or tetrahedron shape, manufacturing tolerances, and wastage during production. This practical consideration may cause the addition of chocolate, and it is wise to put in a safety buffer while planning the manufacturing.
For question 3, it asks us to prepare a uniquely shaped fruitcake whose shape is given by the polar coordinate equation r is equal to 8 sine theta minus 2 sine 4 theta. This shape is generated around the polar axis and has a height of 8 cm in the vertical direction. We need to prepare enough mixture to produce 10 boxes of fruity cakes. Therefore, we need to find the volume for one box of fruity cake first by using the triple integrals in cylindrical coordinates, which setting up the limits for the integral r ranges from 0 to 8 sine theta minus 2 sine 4 theta, theta ranges from 0 to 2 pi, z ranges from 0 to 8. During the process of finding the volume of the fruity cake, we also apply the properties of integrals, double angle trigonometry identities, and product to some trigonometric identities. Finally, we have found the mixture volume for a box of fruity cake is 272 pi cm cube, while the 10 boxes of fruity cake is 2720 pi cm cube. After that, we use the web-based interactive computing platform Jupyter Notebook to generate the 3D model graph and the polar plot graph of the fruity cake.
In short, the volume of one box of fruity cake is calculated by applying the triple integrals in cylindrical coordinates. So, the total volume for 10 boxes of fruity cake is then calculated. So, the volume of mixture for one box of fruity cake is 272 pi centimeter cube. So, if for 10 boxes of fruity cakes is 2720 pi centimeter cube. However, there might be some deviation in the actual production of cakes. For example, the volume of fruity cake may shrink or have other changes. So to improve this, measuring and recording can be done several times to ensure the quality and consistency.